Hello, welcome to this Learn tutorial. In this tutorial, we're going to be talking about Python sets, how you create them, how you add stuff to them, and what they're really good for, because they're really useful in some situations. Okay, so let's get started. So the first thing you need to know is that you create Python sets using curly brackets. So for instance, if I just want to create a set of animals, I just do my set, and let's just add some animals, cat, dog, mouse. There you go. And if you look at them here, they're pretty much like how you'd create an empty list, a list with items in Python, but instead of using square brackets, you use the curly brackets. And because of that, you create a set instead of a list. And if you type in my set, there you go, it's got all of the items. There we go, mouse, dog, and cat. Now you'll notice those aren't in order. And we'll talk about that in a bit as to why they're in order and what that means. Okay, so you create them using the curly brackets. If you wanted to add an item to a set, then you use the add method, which works pretty much in the same sort of way that you'd use the append method for lists. So we do myset.add, and let's add a chicken to there. There we go, chicken. There we go. And there you go, my set.add chicken. And now, if we go my set, you can see that it's now got 4 items: chicken, mouse, dog, and cat. So that's how you add items to a set. Just use add, which is super duper simple. And if you want to remove an item, then you just use my set.remove. Let's remove the cat. There we go. My set.remove cat. And now, there we go, we've got 3 items in there. Also, you can use the .remove method. If you want to remove something, but you want to use the item that you just removed, then you can use the myset.pop method. There we go. So let's just do x equals myset.pop. And what that will do is it will pop, well, it's the last it'll pop the last item here in the set off it. Let's have a look. There we go, which is chicken. Oh, where's it at? No, in fact, it's popped the first item, sorry. It pops the first item from the set that happens to be at the start at that moment. Sets are unordered, so you generally will have no idea what item it's going to pop. So you maybe don't want to use that. Or if you just want to process through each item in turn and you don't really care what order you pick them out in, then it works really well, because it does remove it from the list, just like the remove method here. But it keeps the return value. It actually returns the item that it's just popped, and you can use that to save that to a variable, which is good. So we covered the .remove, which is fine, and you could pop item using pop. You can also loop through your sets. So there's my sets. We could do 4. Oops. Oh, let's just move back through there. 4 item in my set, and we could just print. Let's just print it to show you what it's going to do. Print item. There we go. And it will print all the items in the set, which is great. However, again, it won't necessarily print it in any particular order. It will just sort of print it out randomly. If that doesn't concern you, it's not a problem. But if you do want to, say, print out a list of items in alphabetical order, then you're going to have to do, convert it to a list first, or at least convert the items to a list. So you want to do like L equals list my set, which shows there's the L. There you go. So it's converted it to a list, and then you can do L.sort. There we go. And then you could print out, there you go, it's sorted the items in alphabetical order. And you could print them out then if you wanted. But anyway, you can loop through them just like you do normal sets. You can't add duplicate items. So here, if I've got dog and mouse in my set, let me just show you my set again. Oops, what's I just here? I clicked on something. There we go. If I click my set here, if I do my set.add and I try to add mouse again, there we go. It'll say, oh, look, yeah, that's added, that's fine. But now when you type in my set, you'll see that it's still only got 2 items in there. So there's no duplicates in sets, which actually can be really useful. So if you've got like a really big list but you don't want any duplicates, like for instance a list of, I don't know, customers' telephone numbers that you want to call, but you don't want to call somebody twice, then convert it to a set, and then yeah, all your duplicates have gone, so that's quite useful. There we go. So sets are unordered as well, as I said before. Here, if I add something now, if I do my set, let's have a look, my set dot add, and let's add chicken again. We have absolutely no idea where that's going to land. There we go. There we go. Oops. And now my set. There you go. So it's added it to the front, whereas you would expect with a list it would add it to the end. Okay, so they are unordered. And the data types you add must be immutable. So really, generally you're going to be okay if you're adding strings or integers or floats. All of the basic data types are fine. But if you start to add like classes or something like that, or some special types, then it might say no, and it might have a bit of a fit here and throw an error. Okay, good. So there's the basic introduction to Python sets, which is all very well and good. But you're probably thinking, hang on, this is like a really rubbish list. You know, you can't add duplicate items, and you can't sort them because everything's just getting added in a really random order. Why would I bother using Python sets? Well, it's because Python sets means that you can actually use what's known as set theory. And you can start to do all these wonderful comparisons between sets. So let's say, for instance, here, I do set A equals, and let's do A, comma, B, comma, C. There we go. So I've got set A here, and I do set B here, and I do, oops, I've just done that completely wrong. Set A is not that. Get confused with a list. There we go. Set A. There's set A. Thank you. Set B is, let's try again. C, comma, D, comma, E. There we go. And so I've got two sets. And what I can do is I can use these methods here, the union, intersection, difference, all these 6 methods here, and I can do some pretty clever stuff. So let's have a look at the first one, union. So what a union does is it takes 2 sets, like set A and set B here. Yeah. And what it does is it joins them together to make a third set. So you can do set C equals set A dot union brackets set B. There we go. And what it will do now is it will combine all the elements from set A and set B. There you go, brilliant. So we've got A, B, C, A, B, C, C, D, E. Combine them all together, and now you've got A, B, C, D, E in some crazy order. So that's really, really useful if you've got 2 sets and you want to combine them into one big set with everything in there, but chuck away all the duplicates. Then that will do that incredibly quickly. So that's a union, and again, you could do that. You can convert 2 lists into sets, or take all the items from 2 lists into sets and do that. But that's pretty clever, but it gets even more clever. So the next one is intersection. So this is where if you've got 2 sets here, like set A and set B, but you only want to find out which items belong in both sets, then this intersection method can be really, really useful. So here, set A and set B, set A, set B, the only intersecting item should be the C here. So let's have a look. So we'll just overwrite set C. Set C equals set A dot intersection brackets set B. There we go. And there we go. And now if we do set C, there you go. So that's really, really useful if you want to find out which items are in both sets. There you go. So that's the next one. That's really, really useful. The next one is difference. And what this does is you take set A, you give it set B in this difference method here, and it tells you all of the items that only appear in set A. Okay, so don't appear in set B on their own, or don't appear in both set and set B. So it's the ones that only appear in set A. So let's show you that one. So set C equals set A dot difference set B. It tells you the difference between set B. So it should return only A and B. Oops. Set B, there we go. Hey, that's better. So now if we do set C, there you go. So this now has returned only the items that are in set A, and it's told you that it's got A and B in there. So again, that's really, really useful in certain situations. If you want to find what unique values are only in this one and don't occur in any others, then that's really useful. The next one is symmetric difference, which is similar, and this basically, it returns all the items that are unique to either set. So all the items that are in set A that aren't in set B, and all of the items combined with all the items in set B that aren't in set A. So I'll let you show you that one. So set C equals set A dot symmetric difference set B. There we go. And now, there you go. It's returned A, B, and D, and E. So it's got the A and B from set A, D and the D and E from set B, and it's chucked away this C because C appears in both of the other ones. Okay, so that's symmetric difference. And the last two are a little bit different. These are subset and superset. And what this does is basically it tells you if subset tells you if set A is part of set B. Or in other words, if set A contains all the values in set A also appear in set B. So it's kind of a smaller set. So all the values, in order for this to work with subset, everything in A has to be in B. And B can have more. So B could be a bigger set, but whatever is in set A must be in set B. So, and this doesn't return another set, it just returns a true or false, whether it is or isn't a subset of set B. So let me show you, let's just do that. So if we do set A dot is subset set B, and it will say no, because at the moment it's not. A has values that don't appear in B. So let's just change here. Let's do set A equals, let's imagine it's just a subset of B. So let's say set A has just C and D in it. So C, comma D. There we go. So now set A contains the values in set A all appear in set B, and therefore it should be a subset. Let's have a look. There you go. True. Good. True. So A is part of B. It's got all the values in A appear in set B. Good. So that's a subset, and the converse of that, the opposite of that, is superset. Okay, and this one here, so basically it looks to see if everything in set B also appears in set A. So B kind of can exist inside of set A. So let's just do that. So let's just show you that. In fact, we'll do it the other way around because I don't want to remake the whole thing. There we go. Where are we at? There we go. So we've got set B, and then set A. There you go. So what we'll do here is we'll just do set B dot is superset brackets set A. There you go, and it is a superset because all of the items in set A live inside, also exist inside of set B. So it's the biggest, it's a superset of set A. There you go. So those are the really useful, all these functions are really, really useful in sets. So sets, you've got really two main reasons to use it. Number one, if you're just wanting to have some kind of collection, like a bit like a list of items, but we want to make sure you don't have any duplicates and you don't want to start messing by saying, okay, is it in this? Is it in the list? Or is it not in the list? And if it is, don't add it. But if it isn't, do add it. With a set, you get the same kind of usage, but you don't have to worry about chucking anything out. You can try and add it, and if it's already there, it just won't duplicate it, which is really useful. And the other use for sets, the only other real use, is in this set theory maths here, where you can use all sorts of functions here. These are pretty rarely used in general programming, but some programming problems that you need to solve, these are really, really useful and solve it really, really quickly. So things like intersecting items, really common, or joining two. If you wanted to join two lists of items, but you didn't really care about, you didn't really care about the order of them, and you didn't want any duplicates, then using sets instead of lists would be perfect. Or finding the difference between different things. These are really, really useful. Okie dokie. So that's sets. If you have any questions or if any suggestions for other tutorials, then please let me know. Thank you very much.